Hi everyone. In this lecture video, we'll be discussing the concept of inequalities involving modulus, and following that, we'll be doing a few problems on this topic also. So here we use the concept of vectors to discuss this topic. Like vector addition, subtraction is mainly used, and even we use triangle inequality here. So let's understand this topic now. Say whenever you want to represent a complex number, you can always represent using a vector of 2 dimensions. So let's say, for example, this is the real axis and this is the imaginary axis. If I represent a point P representing Z1 here, another point Q representing the complex number Z2, then in vector notation, we can just say OP vector represents Z1 and OQ vector represents Z2. And you already know how to add two vectors. So we'll use parallelogram law of vectors here. So let's say, for example, complete a parallelogram taking a point R here. So with these OP and OQ as adjacent side, when you complete a parallelogram, by triangle, you know that by parallelogram law of vectors, the vector OR is the resultant of vector OP and vector OQ. So OP plus OQ, and that's nothing but Z1 plus Z2. So if the vector OR is Z1 plus Z2, this means R represents the complex number Z1 plus Z2. So if you now write down the distances, the distance of P from origin is mod Z1, the distance of Q from origin is mod Z2. And since opposite sides in parallelogram are equal, if OQ is mod Z2, PR is also mod Z2. And the distance of R from origin is modulus of Z1 plus Z2 because R represents that complex number. So now here you can write two inequalities. Consider triangle OPR. When you consider triangle OPR, we can write two inequalities in a triangle. So there are two inequalities in a triangle. The first inequality is sum of any two sides is greater than or equal to third side. So basically, when they form a triangle, only greater than will hold, and equal to will hold when the points are collinear, but still we write it under triangle inequality. Equal to holds when the points are collinear. So sum of two sides, I can take OP plus PR greater than or equal to, the third side is nothing but OR. So this OP plus PR greater than or equal to OR. So one of them is mod Z1, the other is mod Z2, and OR is mod of Z1 plus Z2. So you will get here mod Z1 plus mod Z2 is greater than or equal to mod of Z1 plus Z2. And if this is greater than this, it is same as writing mod of Z1 plus Z2 is less than or equal to mod Z1 plus mod Z2. This is the first inequality that we get. Later we'll club all of them. So this is the first one. Let us put this in a box. And the second triangle inequality is difference of any two sides. Difference of any two sides is less than or equal to third side. Less than or equal to the third side. So we don't know which side is greater here while subtracting. So when you write OP and PR, we don't know which is greater. So we'll put a mod when you subtract greater than or less than or equal to third side. Third side is OR, which is mod of Z1 plus Z2. So this is nothing but mod of mod Z1 minus mod Z2 less than or equal to mod of Z1 plus Z2. This is the second inequality. So combining 1 and 2. So what is the conclusion we get? Combining 1 and 2, we get mod of Z from the first one, mod of Z1 plus Z2 less than or equal to this. From second one, this is less than this. So before this, you can write modulus of mod Z1 minus mod Z2 less than or equal to mod of Z1 plus Z2 less than or equal to mod of Z1 plus mod of Z2. So this is what you get by combining both the inequalities. Now we can write one more inequality with subtraction of Z1 and Z2 by drawing another triangle here. Let us do that in a different diagram. So let's suppose we again represent the same diagram first. That is, this is OP, this is OQ. And when you make a parallelogram, this was a OR. So if you draw the negative vector of Q, this is a Q dash, this is minus Z2. This is Z2, the negative vector would be minus Z2. This is anyway Z1. So you can make a parallelogram with OP and OQ dash as adjacent sides. And you'll get a parallelogram here, OR dash. So here OR dash would represent OP plus OQ dash again by parallelogram law of vectors. What does the parallelogram law state? If you add the vectors along two adjacent sides, you'll get the vector along the diagonal through same point. So this is Z1 plus minus Z2. So that is Z1 minus Z2. So clearly the point R dash represents the complex number Z1 minus Z2. Now in the diagram, the distance OP is mod Z1 The distance OQ dash is mod of minus Z2, but mod of minus Z2 is same as mod Z2 anyway. So you can write this as mod Z2 itself. Opposite sides are equal. And this is mod of Z1 minus Z2. If you now apply triangle inequality again, so we write the first triangle inequality. So I numbered as 1 and 2 earlier. Now I'll number it as 3 and 4. So the sum of two sides would be OP plus PR dash greater than or equal to third side is OR dash. And difference of two sides is OP minus PR dash. Put a mod for this. Less than or equal to third side is again OR dash. So this is nothing but mod Z1 plus mod Z2 greater than or equal to mod of Z1 minus Z2. And this is same as mod of mod Z1 minus mod Z2 less than or equal to mod of Z1 minus Z2. So from 3 and 4, what is the conclusion you are going to get? So from 3 and 4, so when you combine, you'll get modulus of mod Z1 minus mod Z2 less than or equal to mod of Z1 minus Z2 less than or equal to mod Z1 plus mod Z2. This is similar to what we got earlier. Earlier you got a plus here, now you got a minus. So if you combine all of them, the final conclusion would be mod of mod Z1 minus mod Z2 less than or equal to mod of Z1 plus or minus Z2. Middle one you can take plus or minus. Last one is mod Z1 plus mod Z2. So all the inequalities together can be clubbed like this. So whenever you solve inequality question, either you can use this as a direct formula. Otherwise, you just have to use the two concepts which I told here. Sum of two sides greater than or equal to third side. Difference of two sides less than or equal to third side. So these are the concepts which are supposed to be used. Then we also have to use some concept of circle as well as ellipse. So for a circle, you know, the definition is when there is a fixed point C, if P is a moving point, if P moves in such a way that this distance is always a constant, P will trace out a circle. So CP is equal to R, the locus of P would give you a circle. Now in complex number notation, normally you can write this as some complex number Z0, this as Z. This is radius R. CP can be written as distance between two complex numbers means we usually subtract them and take a mod that is equal to R. So this would represent a circle equation. So what does this mean? This means Z lies on a circle. Z lies on a circle with center Z0 and radius R. With center Z0 and radius R. And in case you write mod of Z minus Z0 greater than R or mod of Z minus Z0 less than R, what does that mean? This implies Z lies outside the circle because this is like CP greater than R, P lies outside. This is like CP less than R, which means P lies inside. So Z lies outside the circle. Outside the circle. And here Z lies inside the circle. Which circle? The circle with center Z0 and radius R. That is already specified there. Same thing you can write here. And in case if Z0 is origin, you can take it as a special case also. So you can also write mod Z greater than R, mod Z equal to R, mod Z less than R. So here Z lies outside the circle. Outside the circle. Here Z lies on the circle. And here Z lies inside the circle. Inside the circle. What kind of circle? With center Z0 and Z0 is origin. With center origin and radius R. With center origin and radius R. That's what we can conclude for circle part. So we'll do more about circles later, but to solve inequality question, this much is enough. Now coming to the concept of ellipse here. So generally the definition of ellipse is if A and B are two fixed points, if there are two fixed points, and P is a moving point. P is a moving point. So if the point P moves in such a way that sum of distances from two fixed points is equal to some constant which is greater than the distance between them, P will trace an ellipse. So you can just say in this case, locus of P is an ellipse with A and B as foci and K as length of major axis. As the length of major axis. And if suppose A represents the complex number Z1, B represents a complex number Z2, and P represents a complex number Z, the distance PA means you have to subtract the complex numbers, take a mod. PB means subtract these two, take a mod equal to K. where k should be greater than distance between a and b means you have to subtract these two z1 and z2 take a mod. So for this case, the locus will be an ellipse. And in case if it is equal to, you got ellipse. If it is greater than or less than, what do you get? Here P is on the ellipse. Greater than means P lies outside the ellipse. Less than means P lies inside the ellipse. So you can just make a conclusion. If you get PA plus PB greater than K and PA plus PB less than K, where K greater than AB, this will hold, of course. So P lies outside the ellipse. Here you say P lies outside the ellipse. The same ellipse which I was talking here, that is with A and B as foci, K as length of major axis. And here you can say P lies inside the ellipse. So while doing the problems, you can also consider this inside the ellipse. Again, we'll do more about ellipse at the end of the chapter in the topic called loci in a complex plane. Right now, whatever is required for inequality problems, I just discussed only that part. So let's begin with the questions now. So we have a question. All complex numbers z1 and z2 satisfy these two equations. What is the minimum value of mod of z1 minus z2? Now, basically, mod z1 equal to 12. What does this imply geometrically? We can solve this question geometrically. Z1 lies on a circle. This means Z1 lies on a circle with center origin and radius 12. With center origin and radius 12. So we'll interpret this geometrically. And what does the second equation mean? Mod of Z2 minus of 3 plus 4i equal to 5. Taking minus common in these two. So this implies Z2 lies on a circle. Z2 lies on a circle with center 3 plus 4i and radius equal to 5. Radius equal to 5. So clearly you can see even 3, 4 is at a distance of 5 from origin. So while drawing the diagram, let us use that. So we draw a circle for the first one with center origin, radius 12. So PZ1 is on that circle. For second circle, center is 3, 4. And you know that 3, 4 is at a distance of 5 from origin. So mark 3, 4 here. So draw a circle with this as radius. This is radius of second circle is also 5. So this distance is also 5. So with 3, 4 as center, draw a circle here, passing through origin like this. So the second point Z2 lies on this. So let us take it here. It can be anywhere on the circle, but P also can be anywhere here. Q can be anywhere here on the circle. And the distance between them will be minimum when P is here and Q is here. So for this position, they are closest. So if P is chosen here and Q is chosen here, this is the shortest distance. And clearly because the radius is 5, this is 5 and this is 5. So I think I can draw a better diagram once. Let me draw that. So this is origin. This is P, this is Q. This is 5, 5 because this is 3, 4. And the total distance was 12. So this would be 2 because the radius of bigger circle is 12. So clearly PZ1 is here, QZ2 is here. PQ minimum. PQ is mod of Z1 minus Z2. So PQ minimum, the minimum distance is mod of Z1 minus Z2 minimum. And clearly you can see that that value will be 2. And if they ask you maximum distance, probably this P can be chosen here. And this would become 10 plus 12, 22. If they ask you max of PQ, then it is nothing but 12 plus 10, which is going to be 22. But in the question, they ask minimum only, so 2 would be the answer. So you can mark second option as the answer. Now let's move on to the next question. So this question is actually related with ellipse concept. So clearly you observe, if P is Z, A represents the complex number 1 and B represents the complex number minus 3. Clearly this distance AB is nothing but a mod of 1 plus 3. Because they're complex numbers, it is mod of Z1 minus Z2, which is 4. And clearly K is 8 here. So K greater than AB. So locus of P is ellipse. So you can say locus of P is an ellipse with minus 3 and 1 as foci. And K equal to 8 is major axis. major axis. Now, if you have to find out mod of z minus 4 range, so basically this is the distance between z and 4. You have to find the minimum value and maximum value and then write the range. So let us first draw the ellipse. Mark the center also here. The foci are -3 and 1. So one focus is at -3, another focus is at 1. And the midpoint of these two should be the center. So -3 plus 1 by 2 is -1. This should be the center. So -1 here means -1 plus 0i and 1 means 1 plus 0i. So origin would be somewhere here. So center of the ellipse is here, but origin is somewhere here. Now when they give major axis length as 8, this total length is 8. So this would be 4 and this also would be 4. And you have to find out mod of z minus 4, so which is the distance between z and 4. So you know that this distance is 4. From here it is 4. From origin it is 3. So this is 3, 0. 4, 0 would be somewhere here. And what is z basically? If equal to is there, it is a point on ellipse. Here z lies inside the ellipse. So here clearly because less than is there, z lies inside or on the ellipse. Equal to means it is on the ellipse, less than means it is inside the ellipse. So the set of points can be inside or on the ellipse. Z can be anywhere here. So one of the points, it can be on the ellipse also. So mod of z minus 4, if I want the minimum value, like for example, if I know these points, say C and D. So what is this point? From here it is 4 unit, from origin it is 5 unit because it is 1 unit. So this is -5, 0. So Z is one of the points either inside the ellipse or on the ellipse. The point closest to 4 is this one, C. So if this is some P, so Z minus 4 minimum would be the distance CP, which is 1 unit. And if I want Z minus 4 maximum, it would be the distance from P to D, dP. And that would be from here, if you measure the distance, this is 1 unit and this is 8 units. So total it is 9. So therefore, if you want mod of Z minus 4 range, you can write minimum comma maximum, which is 1, 9 closed interval. So if you look at the options now, clearly C will satisfy the required answer. Now let's move on to the next question. If a complex number Z lies on a circle of radius half, they have not mentioned the center. So let us take some center of our choice because you don't need the center. It's mainly about radius. We can choose as per our choice. Let the center be some origin. Then you can say Z lies on a circle with center origin radius half. So mod Z is already half. Now you want to find out where will the complex number -1 plus 4Z lie. So let us assume that this complex number is some W. Then you can write this as W plus 1 equal to 4Z. Applying mod on both sides will give you mod of W plus 1 equal to mod of 4Z or 4 times mod Z. And since already mod Z is half, you write half here. 4 into half would be 2. So mod of W plus 1 is half means what does it mean? W lies on a circle with center -1, provided Z was on a circle with center origin. So if I change this, this will also change. But we are not interested in the center. We are just interested in the radius, with radius equal to 2. So the required radius is therefore 2, which is second option. Now let's move on to the next question. We have to find out the greatest and least value of mod of Z1 plus Z2 given Z1 value, mod Z2 value. So you know that mod of mod Z1 minus mod Z2 less than or equal to mod of Z1 plus or minus Z2, will take plus here, less than or equal to mod Z1 plus mod Z. So using this, you clearly know that if you take modulus of Z1, it will be root of 24 square plus 7 square, which is 25 square under root, which is 25. So here you can write 25 minus 6 less than or equal to mod of Z1 plus Z2 less than or equal to 25 plus 6. So clearly you will get 19 less than or equal to mod of Z1 plus Z2 less than or equal to 31. So the greatest and least value are 31 and 19. You don't have a combination of both. You have 31, but 19 is not there. Here 19 is there, 31 is not there. So we'll mark none of this. So the answer would be 31 and 19, which is not present here. So D is the answer. Now let's look at the next question. If mod of Z minus 4 by Z is 2, what is the greatest value of mod Z? So what we do is start with mod Z because you wanted mod Z. And since you have Z minus 4 by Z, subtract 4 by Z, add 4 by Z. So you know this is Z1 and this is Z2. This is like mod of Z1 plus Z2. You can write less than or equal to mod Z1 plus mod Z2. Mod of first one plus mod of second one. You can write 4 by mod Z. And since already they gave this value as 2, you can say mod z is less than or equal to 2 plus 4 by mod z. So we need to solve this and find the greatest value. So we can write this as mod z whole square less than or equal to 2 mod z plus 4 multiplying throughout with mod z. That is same as mod z square minus 2 mod z less than or equal to 4. To simplify, just add 1 so that you can make this a perfect square. So mod z minus 1 whole square is less than or equal to 5. So you can just say mod z minus 1 lies between minus root 5 and plus root 5 according to this. And since you want greatest value, we'll just choose this and say mod z is less than or equal to root 5 plus 1. So what is the maximum value mod z can have? Root 5 plus 1. So let's look at the options now. So we have option D as the right answer. So with this, we have completed inequalities involving modulus.